Hello, hello. So we're going to do a quick introduction into hypothesis tests. This is what we would have talked about during class, but things are crazy. So what is a hypothesis test? Well, firstly, just know that it is one way we have of doing inference in statistics. So inference means we are using a sample and data from a sample to make some type of conclusion about the population. One way to do that is with a confidence interval, like we've already talked about. The other way to do that is with a hypothesis test. So to kind of demonstrate what a hypothesis test is doing, we're going to do a couple of little examples. So I'm going to start with this little pick a card, any card. And normally I would do this in person, but of course we are not in person. So I have a stack of cards, 52 cards, brand new, and I start having students pick a card. And the goal is to try to get a black card because the first student who gets a black card gets a special fancy prize. So we start drawing. The first person picks a jack of diamonds, not a black card, it's a red card. So we're going to try again. I'm going to click the again button to get a new card. Our second card is an ace of hearts. I'm going to click again. Third person gets a four of hearts. Fourth person gets a king of hearts. Fifth person gets a queen of diamonds. So what I would ask right now is how many times in a row, because probably by this time you're starting to think, okay, what's going on here? You're starting to question whether this deck of 52 cards is truly a regular, normal, brand new deck of 52 cards that has all the cards that it should. You're questioning that kind of initial assumption that you may have had that it was a normal deck of cards because I keep getting red cards. I still haven't gotten a black card, and that's kind of crazy. So what you were doing in your brain, whether you realize it or not, is the basis of a hypothesis test. Let's do another example. So let's say we flip a coin, right? We know in our minds our initial assumption, if it's a fair coin, is that we should have about a 50-50 chance of getting heads or tails. So if I flip a coin and I get two heads in a row, I'm probably not going to freak out and call the authorities because you have a fake coin. Because even though we know we should be getting about 50-50 heads, tails, it's not that unlikely. In fact, it is about a 25% chance that I could flip two coins and get both heads. So really, I'm not going crazy yet. Three heads in a row has about a 12.5% chance of chance of happening. So again, I want you to think about how many heads in a row would it take for you to start questioning the fairness of this coin before you would have doubts about your initial assumption that this was a fair coin. How many heads in a row would it take for you to start questioning everything you thought was true? Usually people will start to question at around 5 heads in a row. And believe it or not, that actually crosses a kind of general threshold that statistics uses, which is a 5% chance. When something becomes less than 5% likely to happen, that's typically where people start to question, and that's kind of true here as well. The whole idea behind a hypothesis test is that we hold an initial assumption, right? We have this thing that we believe to be true until an occurrence becomes really, really unlikely, and then we start to question. Let's look at another example. I'm going to go back to what I used to introduce the concept of a sampling distribution, which was a sampling bowl. So this is the sampling bowl. It's got beads in it, white ones and red ones, and there were 21% red beads in the bowl. At least that's what I told you. So we took repeated samples to build up what we called our sampling distribution. That tells us, for many, many samples, what can we expect to get in terms of proportion of reds in the bowl. So if I were to show you, this top one is for samples of size 25, what we can expect for the proportion of reds. The bottom one is for samples of size 100. So if I told you that I went to that sampling bowl and I picked a random sample and I got 60% reds, right? If I look at my graphs that are telling me what I can expect if it were really true that 21% red beads were in the bowl, is 60% red in a sample very likely? Not really. Is it possible technically? I mean, yeah, it's possible, but it's not very likely. Okay, so here's our big question. In a hypothesis test, our big question is, could this observed occurrence be the result of chance variation, right? We know when we take samples, we're not always going to get a perfect representative sample. Sometimes it's going to be off in one direction or the other. When I pick a sample of beads out of the sampling bowl, I'm not always going to get exactly 21% red beads, even if there truly are 21% red beads in the bowl. There's going to be some off in one direction or the other. So could this observed occurrence, could my sample have just been a result of chance variation, just that little bit off in either direction? Or is this occurrence so unlikely to happen, so rare, so out of the ordinary, that it makes us doubt our initial assumptions? Okay. When I say doubt, there are two main things that we could be doubting. We could be doubting our initial hypothesis, right? So with the beads, right, we could be doubting, if I get a random sample that has 60% red beads, right, I could be doubting maybe the bowl doesn't actually have 21% red. Maybe it has more than that. So maybe that's what I'm doubting. For the coin example, right, once we get so many heads in a row, we start doubting, is this a fair coin? Does it actually have both a heads and a tails side? With the deck of cards, the more red cards I get, the more unlikely that becomes, the more I start to question, is this a fair deck of cards that has all the amount of cards that it should? So that's one thing we could have. We could be doubting our initial hypothesis, but sometimes we're doubting the assumptions or conditions that we check. Mainly, sometimes we question that random or representative sample assumption, right? If we take a random sample of beads out of the bowl and I get 60% red, maybe the bowl does have 21%, but maybe I didn't actually take a random sample. Maybe I lied and I handpicked my sample. So that could be what we're questioning as well. So it's typically one of those two things. There could be an issue with one of our other conditions or assumptions as well, right? But that's what we mean when we have doubts. We're doubting something in our initial hypothesis, but we may also be doubting whether we have a random sample or not. Right. I'll get into this more in the actual lesson video that you're going to watch before class on Thursday. But this is kind of our 4 steps of a hypothesis test. We're going to start by stating our hypotheses. We have a null and we have an alternate. We're going to check our conditions, just like we always have. We're going to calculate a probability of getting the sample result that we got. And then we're going to use that probability to determine and write a conclusion. We're going to determine, based on that probability, do we have doubts about our hypotheses? And we write a conclusion. Okay, so those are our 4 steps. So that's just a general introduction. And then the last little thing I wanted to throw in here, and this is just kind of more taking real life situations and using it in context. So a lot of times when we think about conditions, right, especially in a class where you're doing things in a certain order, you might find yourself, oh, is this a random sample? It may not be a random sample, so I'm going to stop doing the problem and not do anything else because it may not be a random sample. So I wanted to use this as an example. Sometimes we can use a hypothesis test to talk about or make a statement about representativeness. Remember, one of the things I could be doubting in a hypothesis test, I could be doubting, do I actually have a random representative sample? So I pulled this example. This was a friend posted this image on Facebook, and I thought it was a really good way to talk about representativeness of samples. So we have Congress. Congress has 535 members in it. Now, obviously, it's not a random sample, right? We actually vote for people in Congress. We put them in that position. They run for it. There are a lot of qualifications that come to it. So it's not a random sample. And we realize that. But as Congress, they are literally representing us as Americans. And maybe we're questioning whether or not they truly are a representative sample in terms of its makeup, in terms of millionaires, their race, their gender, their age. Do they actually represent Americans? So if I wanted to use a hypothesis test to make a statement about representativeness, what I would look at is, right, I have a sample of people that are 51% millionaires. If I were to take a random sample of people in America there's only 5% millionaires. If I were to take a random sample of people in America, how likely would it be for me to get a random sample that had 51% millionaires in it? Not very likely. Same thing could be said about white men. So if I have 77% in my sample, right, there are only 31% white men in America. So if I picked a random sample of people in America, what are the chances that I would pick a random sample that had 77% white men? Is it possible? Yeah. But is it likely? Not really. Right. So this makes the statement of, yeah, it could happen. but it's not very likely to happen if I just picked a random sample. Same thing could be said for gender, right? 20% women in Congress, 51% women in America. If I picked a random sample of people in America that are 51% women, right? Is it possible for me to pick a random sample that had 20% women? Sure. But is it very likely? Not really, right? So again, we can use that hypothesis test to just make a statement of, if this were truly a representative sample in terms of these characteristics and these facts about the person, then a random sample would be pretty similar to the actual picked sample. So it's a good way to make a statement about representativeness without actually having a random sample. So that is one little real life example I wanted to pull in just to give you something to think about the ways we can use a hypothesis test and statistics, even if we don't necessarily have a random sample. So that is it for this little intro video. So the lesson video is going to be separate. So make sure you watch that, take good notes, and we will come back next time and talk about it. Bye, y'all.